So in this video, we're going to go over solving a three-part linear single variable inequality. And the hallmark of a three-part inequality is that we're going to have two inequality symbols showing up that break our inequality into three sections, which is why it's a three-part linear inequality. But the solution process is going to be the same as it is for a standard two-part linear inequality. Start by rewriting the equation. I'm going to show a little bit more level of detail for this one than I usually would. So we're going to go plus 2x. I'm going to leave a lot of space. Less than or equal to 25. And the idea is, instead of doing the same thing to both sides, which is what we're accustomed to doing, we're going to do the same thing to all three sections. We have a section here, a section here, a section here. The idea in a three-part linear inequality is to isolate the x in the middle so we know which numbers are bounding the x on the left and the right. So to get the x by itself, which is the focus, you just look at the middle part of the three-part inequality and you say, what can I do to get the x by itself? Well, here I can see that subtracting 5 would help get the x by itself because 5 minus 5 would be 0. 2x plus 0 is 2x. But if I subtract 5 from the middle, I also need to subtract 5 from the right side, and I need to subtract 5 from the left-hand side as well of the three-part inequality. So you bring down your work. Minus 5 is negative 10, or minus 10. 5 minus 5 is 0. 0 plus 2x is 2x. And I have less than or equal to 25 minus 5 is 20. And now I have two x's in the center section. I want to isolate a single x in that center section, so I'm going to divide by 2, because 2 divided by 2 is 1, and whatever I do to one section of the three-part inequality, I do to all three sections of the three-part inequality. So I wind up with negative 5 is less than or equal to x is less than or equal to 10. And then it says represent the solution in interval notation. I have it in inequality notation. In interval notation, I see that I have two numbers as my bounds, negative 5 and 10. This says that x has to be greater than the negative 5, but it can also be equal to the negative 5. So x is between negative 5 and 10, but can also be equal to each of those. So x is an element of the interval from negative 10 to 10. X is between these two numbers. So there's interval notation. Set notation, I would just say the set of all x such that, and then I would put my three-part inequality that I solved right here into the set notation. So I would go negative 5 less than or equal to x less than or equal to 10 and close my set notation. And on a number line, so if I were doing a number line, I would establish my number line. I would establish my 0. I would establish my negative 5, which makes 5 about here, which makes 10 about here. And then I'm going to do a solid bracket. Let's see if I can get bring up a menu here. Let's see. Pen, printer. Oh, come on. Pen. Well, that's not what I wanted. There we go. Ink color. Let's change it to a different color. Black. So negative 5 to 10. Here we recognize that we're including the negative 5 because x can be equal to the negative 5. There's the equal to sign, so put a dark point there, filled in, not open, and x can be equal to 10, so we'll put a point there. And x is between the negative 5 and the 10, so we just draw the line segment from negative 5 to 10. The alternative approach would be to take that number line and do the square brackets to show that the negative 5 and the 10 were included, and then draw the line segment connecting them. So one more example. Looks almost the same as the previous one, but in this case I have a minus instead of a plus right here, and this is going to change how the problem plays out a little bit. So again, I start by writing the problem. Negative 5 is less than or equal to 5 minus 2x is less than, this time is less than 25. So we lost that equal to part as well. I'm going to recognize that to get the x by itself, I'm going to start by subtracting 5 from all three sections of the three-part inequality. Bring down my less than or equal to. Negative 5 minus 5 is the negative 10. 5 minus 5 is 0, but that's going to drop down a negative 2x, which is going to be less than 25 minus 5 is 20. And now to get the x by itself, I see that I'm going to need to divide all three sections of the three-part inequality by a negative 2. And what I want to remember from the previous videos is that this is going to force us to take the inequalities and reverse their directions. So I get negative 10 divided by negative 2 is 5. Negative 2 divided by negative 2 is 1x. And 20 divided by negative 2 is negative 10. And it would be more customary to put this from left to right in ascending order, so I probably want to write the negative 10 first, keeping the inequality pointing at the 10, the negative 10, keeping the inequality opening towards the x, keeping this pointing at the x, and keeping the inequality opening towards the 5. So this would be a more standard form. Negative 10 is less than x is less than or equal to 5. So there's the solution to the three-part inequality. But it does say write it in interval notation. So in interval notation, I would say x is an element of the interval that begins at negative 10 and runs all the way up to 5. But because it's equal to 5, I'll do a square bracket here, including the 5. I don't have the equal to here, so I'll do the open parentheses saying that although 10 is a boundary on this inequality, it is not included as an answer in the solution set. In set notation, I would simply go the set of all x such that, and then I would bring my inequality into the set notation. Negative 10 is less than x is less than or equal to 5. Close off the set notation. And on a number line, here's my 0. Here is my 5, which makes this 5, and this roughly negative 10. Negative 10 isn't included. Let me go in here, pointer options, ink color, change to a color other than black. So at 10, I would put an open circle or an open parentheses to show that the negative 10, although it's a boundary point, it's not included. And I would run all the way over to the 5 with a solid dot to show the 5 can be equal to x, or a square bracket facing this way, and then you draw your line segment connecting those. So it looked like one of these two things on the number line.